Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Okay, so have you ever been looking at online institutions or online advanced secondary schools that can give you a chance to learn and enjoy the beauty of advanced subjects? How are you, everybody who is watching this program? I would like to take this opportunity to welcome all the local, national, and international students who are watching this program. My name is Olenjolai. I am a Tanzanian. I will be using the syllabus of United Republic of Tanzania to teach you about the beauty of advanced subjects. So possibly you are pre-Form 5 students, or maybe Form 5 students, or pre-Form 6 students, or Form 6 students, or grade 12 students, or you are international students. Regardless of which class you are, remember that we'll be focusing on covering the contents of advanced concept for science and mathematics subjects. So we won't talk anything else which is ordinary in this program. We'll be just discussing the stuff which are a little bit advanced. So if you are in that level, or you want to take some preparations in order to get to that level, you are welcome. So I would like to take this opportunity again that I will be your teacher and expecting too many things that we'll be doing together in these sessions, because I will never let you down. So because we really need the interventions and the intimate relationship with God, with this stuff, according to the way they are, the way they look like, and the way that they used to challenge so many students. So let us have a single minute to pray and invite God to intervene our program in order for everything to be happening with particular reason. So our Father who is in heaven, we come before your presence. We thank you for this opportunity. Father, we come before your presence. We are ready in order to receive what you have prepared today about the chemical reactions of Alkynes. We can't do anything without your help. We cannot speak any word without your help. So because you are in me, Father, I would like to invite you right now, and I would like to give you permissions to teach your students locally, nationally, and even international. And Father, I'm praying for all the present and future students who will be accessing these contents. Open their mind to understand, open their mind to remember all of these contents, and open their mind to remember even the previous contents and keep them remembering for the rest of their life, and open their eyes to see opportunities and problems in real life of the mankind which need solutions from this content that we are going to share with them. Father, we thank you because you are with us. Amen. So, we expect you to have serious students, and I would like to take a minute to welcome you once again into our Tanzania Online Advanced Secondary School in Square Bracket, Olenjolai. And secondly, I would like to take this opportunity to welcome one of our official YouTube channel that called Tanzania Online A-Level Secondary School in Square Bracket, Olenjolai. We are in departments of advanced chemistry, and the subject today is called advanced chemistry. And this is the main topic today. We have more than 5 main topics in organic, in chemistry, in advanced chemistry. And one of them is the main topic today that called advanced organic chemistry. And we are about to finish with this session 25. We'll be finishing the chapter 2, which is titled Unsaturated and Unsaturated Hydrocarbons. We dedicate these contents to pre-Form 5 students, to Form 5 students, pre-Form 6 students, Form 6 students, and even the reciters, QT students, grade 12 students, teachers, and chemists. I would like to take this opportunity to welcome you in session 25, which is titled as Chemical Reactions of alkynes. So this actual is, let us go into a quick review of session 24. So in session 24, it has been titled as laboratory preparations of alkyne. So laboratory preparations of alkyne. So I have taught you 4 methods that you can use in chemistry laboratory to prepare alkyne. The first one is called dehydrohalogenation sulfate of vicinal compound. And the second method, we learned about hydration.
Yes.
Hydration sulfate.
Alcohol.
Hydration. So hydration of diol alcohol. And then the same method, we say that hydrolysis. We told you that you can prepare a sign by hydrolysis sulfate of calcium carbide. And the last method, we say that you can also prepare alkynes as a chemical reaction between what? Between alkylides and alkyl halide. Alkyl halides. So this is what we have done. Then we left the homework, which was homework 24, which will do corrections today. But explain briefly the rate chemical reaction of alkyne. So if you have missed session 24, or session 23, or session 21, or session 22, or session 20, you can access them in the playlist called the Advanced Organic Chemistry in our official YouTube channel that called TANZANIA Online A-Level Set School in square bracket OLENJOLAIM. So you'll access all the sessions from session 0 to session 24. Have been published with thanks by God's grace. Now they are publicly accessible. So before we teach about chemical reactions of alkynes, let us start today's session with a very important point that's called the physical properties. Physical properties of what? Physical properties of alkyne. Physical properties of alkynes. So the physical, just to make one sentence, the physical properties of alkyne. The physical property of alkynes are the same to the physical property of alkene. That is simple phrase. Okay, so let us focus on chemical reaction. So chemical reaction, and remember the physical properties of alkenes. Alkenes are the same with physical properties of alkyne. So in alkyne, we told you the physical properties which are actually the same with the physical properties of alkene, physical properties of alkyne. So chemical reaction of alkynes. So we'll teach you more than 3 chemical reactions of alkynes, but I'd like to start with this sentence. So let us start with this sentence. chemical reactions of alkynes are the same to the chemical reactions of alkenes, except the following two things. Except the saturation of alkynes, expressions of alkynes need twice of the reagent, compared to alkene. So the saturations of alkynes need twice of the reagent compared to alkene at the first expression. Again, we say that the speed of chemical reaction of alkenes is lower than the speed of chemical reaction of alkene. Why? Due to high strengths of pi bond in alkyne. Due to high strengths of pi bond in alkyne. So we say the speed of chemical reaction of alkyne is lower than the speed of the chemical reaction of alkene due to the high strengths of the pi bond. Okay. When we say about the twice the reagent required compared to alkyne, it means, for example, if it is hydration or hydrogenation, it means that carbon is single. Alkene has double bond. So to undergo, for example, hydrogenation, then it needs only it needs one molecule of hydrogen. While for alkene, to undergo complete saturations of hydrogenation, then we need 2 atoms of hydrogen molecule. Right? So in this one, it means that now we can form carbon single bond, which is hydrogen, and this reaction can form carbon single bond. But you see here, you need 2 atoms of reagent compared to what's required in alkyne. So these are just the simple examples because I've told you, not actual. I didn't put maybe the number of hydrogen. So you can put maybe hydrogen here, hydrogen. This is simple stuff. from a student. So it means that here you have 3 hydrogen and here you have 3 hydrogen. So here you have 3 hydrogen and here you have 3 hydrogen. Okay, you say that alkyne also contain localized pi bond. Contains localized pi bond electron. Remember the electrons. So alkynes contains localized pi bond electrons. So they can undergo electrophilic addition reaction as how alkynes undergo. The first electrophilic addition reaction is hydration. Remember in alkene, we taught you 5 examples of electrophilic addition of alkene. So hydration of what? Of alkyne. This is the first example. And then just we are giving you the overview, but you have to remember even some other 4 examples of electrophilic additions the alkenes undergo. So we'll be jumping into oxidation, be again focus on ozonolysis, and then just some other few reactions. So hydration. So we say that alkenes react with water in acidic medium and in presence of mercury, and give products which are called the enol. Alkenes react with water. So alkene reacts with water in acidity acidic medium to form acidic medium and presence of acidic medium under there. Under the presence of mercury form an organic compound that we call it enol. Form so in the presence of mercury, we need mercury and sulfuric acid. Mercury and then sulfuric acid to form enol. So this is the first example of electrophilic addition reaction. We won't do too much of revisions. We just to teach you those which are exceptional, because we say that because alkanes contains localized pi bond, so it can undergo electrophilic addition reactions similarly as how alkenes have been undergoing, but you have just to double the number of reagents. So one which is exceptional is called the hydrations of alkenes. So when alkenes react with water in acidic medium under the presence of mercury and sulfuric acid, then the product which will be formed is called the enol. Okay? So the general wave chemical equation, which can help you to remember chemical equation, it is that here we have alkene. Here we have alkene, and this alkene undergo hydration. So we react with water under presence of what? Sulfuric acid and mercury. Then we form a product that we call T. Call it MR. So we form MR. Yeah, the main product is MR plus what? You can have sulfuric acid, but the main product is MR. So general molecular formula this is alkene plus water, the presence of sulfuric or mercury, sulfuric acid, so you have Ara, here remains double with this carbon, still have a silver hydrogen there, 2 hydrogen, and here we have hydroxide. Yeah, that's the functional group of protein. So example 23, complete the following. Chemical reaction with mechanism. This is mercury, this is sulfuric acid, So this one will be your homework 25, and this one will be your homework 25. So we do example 23 Roman 1 and example 23 Roman 4. So I'm still insisting you to learn this chemical reaction with mechanism in order to simplify your level of understanding how the bonds break and how the bonds form. So here we have right open structure of your reactants, and then reacting with short. So the first question you have to ask yourself is water a nucleophile or electrophile? It's nucleophile. But this is an example of electrophilic additional reaction. So electrophile should be added first into organic compound before nucleophile. So for that case, that's why we have sulfuric acid. Why? Because in sulfuric acid, we can break the bond between sulfur, between hydrogen and oxygen to form what? To form hydrogen as electrophile and sulfur trioxide and and hydrogen sulfate. So these are the 6 bonds of what? Of sulfuric acid. So the first step, we should have an electrophile. So we can break the bond between this oxygen and hydrogen, so oxygen and this hydrogen. So when the bond break, then this is partially negative and this is partially positive. That's the first process. So the next step now, we have two bonds. We have electrophile, we have an organic compound with 2 nucleophile and 1 electrophile. So this is alkyne, which nothing has happened to it yet. Then we have electrophile, which is partially positive, plus what? So plus water, which is nucleophile, plus hydrogen sulfate, which is nucleophile. Okay?
Yes.
Hydrogen sulfate is when you break the bond between oxygen and hydrogen. Sulfur remains with 4 oxygen and 1 hydrogen, but still missing 1 bond because we broke the bond between hydrogen and sulfur. Everything is simple. We have been doing this business several times, so nothing here to say to worry about. Unless you forgot what I've been teaching you in previous session, then you can see that these are the miracles. This is something new. No, this is the beauty of advanced chemistry. Okay, so afterward, then we have to remember about the one of the rule guiding electrophilic additional reactions of alkene, which is said is Markovnikov's rules. And Markovnikov's rules state that during electrophilic addition reaction, the incoming electrophile is added to the most hydrogenated carbon. So if that's the case, because now we have electrophile and 2 nucleophiles, so between this carbon and this carbon, which contain the triple bond, this is the most hydrogenated carbon compared to this one. So it means that the bond or the arrow always start from here and pass nearby to the most hydrogenated carbon, and this electrophile will be added into this carbon. So when we do this one, according to Markovnikov's rules, so we have now a double bond, we broke 1 bond, and then this carbon will become, this one become partially negative, and this one become partially positive. So this is partially positive. And then here we have what? Partially negative, but this partially negative will, means it will donate the electrons to hydrogens. And then here we have a single bond between hydrogen and carbon. then plus what? Plus water as nucleophile, and then plus what? Hydrogen sulfate as nucleophile. So we've added an electrophile into the organic compounds. The next step now we have to add what? The nucleophile. So between water and sulfur, because the title of this chemical reaction is hydration. So water will be added as nucleophile into the carbonium ion. So when this water will be added into the carbonium ion, then we have what? We have R, we have a bond with water. It means that a new bond will be formed between carbon and the oxygen, because oxygen is the one that containing lone pair and not hydrogen. And then you have double bond. You have carbon, you have a single bond with hydrogen. Plus what? Plus hydrogen sulfate. So hydrogen sulfate, but still partially negative. Oxygen is overloaded. Oxygen has a capacity of forming only 2 bonds rather than 3 bonds. So you have to break one bond between oxygen and hydrogen. So when you break, oxygen is more electronegative compared to hydrogen. So hydrogen become partially positive and oxygen become partially negative, but oxygen is already saturated. So for that case, we have R, then we have carbon, we have double bond, then we have hydroxide here, then here we have 2 atoms of hydrogen, then we have partially positive, plus what? Plus oxygen, which is hydrogen, oxygen, hydrogen sulfate. Okay, so I think let me write here, hydrogen sulfate. So here you have hydrogen sulfate, okay. But this is partially negative. So now this one is nucleophile, donates electrons to electrophile. And then the final product now is a compound that we call NO. NO, so CH2 plus what? Hydrogen sulfate plus sulfuric acid. So the overall chemical reaction is this. Hydration, and then under presence of sulfuric acid, presence of mercury. So this is inner compound. At the final overall chemical reaction. So for Roman 4, because I gave you a promise, if you did understand, you are allowed to watch this video several times as well as you can until these concepts are built up in your mind. So you have a triple bond between this carbon, and then here we have Si like this. So here we have hydration or hydration, supported nucleophile, and they have a bond between sulfur and oxygen, double bond between sulfur and oxygen. You have a single bond between oxygen and hydrogen. So if you didn't understand the first, the example 23 Roman 1, now you can stop writing and listen how I do the mechanism for example 23 Roman 4. So the bond here break down. This is partially negative and this is partially positive. So you have phenyl as substituting group like this. And here we have triple bond. Then here we have CH2, H5, plus what? Plus water, plus what? And here we have hydrogen, plus partially positive. Then you have oxygen, sulfur dioxide, like this. Okay, so you have the electrophile, neutrophile. So the bond break according to. So for this case, you see that there's no mostly hydrogenated carbon, because this carbon does not have hydrogen, this one does not have hydrogen. So you are free to add the incoming electrophile into any of these two carbons, according to Marconi's rule. So suppose that we are adding the incoming electrophile into this carbon. So then, the next step, we have what? We have phenyl. Okay. So carbon, but because this one becomes partially positive, we have double bond there, and this now is hydrogenated carbon. Then we have CH2, H5. And write also the open structure of this molecule, and this is water plus what? Plus oxygen, sulfur dioxide, which is hydrogen partially negative. So we have add water as neutrophile, right? Into the carbonium ion. So once we do that, I believe you're enjoying the beauty of advanced organic chemistry, or special chemical reactions of alkenes, and the special hydration of alkene. So for that case, now we have phenyl and we have water attached in this carbon, and still have double bond, and here we have an SR substituent group, or SR as just a continuation, not a substituent group. Then plus what? Plus oxygen, hydrogen. Yes, this can probably write this way. Hydrogen sulfate. This is hydrogen sulfate. So I've been doing mistake. Let me do minor correction. Here. I just write this one and let me confirm with you. If you write the molecular formula of this hydrogen sulfate. So this is the way that we write it. Oxygen, sulfur dioxide, hydrogen sulfate. So here we have hydrogen. Then it's fine. Here I made a mistake. We have 3 oxygen because the other oxygen is here. Yeah, here everything is okay. Here I made a mistake. So we have oxygen partially negative, sulfur dioxide, hydrogen. So this is hydrogen sulfate. Okay. So if that's the case, we say okay, so the bond break in this way, so this becomes positive. We have phenyl. We have double bond. We have single bond with carbon, hydrogen, 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 hydrogen. Plus what? Plus hydrogen is partially positive. Plus hydrogen sulfur dioxide. So this hydrogen sulfur dioxide become as nucleophile and donates electrons to what? To hydrogen. So now our final product will be phenyl. Phenyl enol organic compound. We have OH here, we have double this carbon. Then we have CH2, CH3, plus sulfuric acid. So overall hydration, overall reaction, it is overall reaction. So if you have gone through those two examples that I've solved it for you, now you can try example 23 Roman 2 and example 23 Roman 4 yourself. I believe everything is simplified. Okay, so this is the one of example of electrophilic additional reaction for alkyne. So you have to remember the rest. So right now we'll be focusing into other chemical reactions of alkene, and this is second reactions or secondary chemical reaction, which we call oxidations of alkenes. Oxidations of alkenes. Alkenes can be oxidized. Alkenes can be oxidized. So alkenes can be oxidized by different oxidizing agents. So the first oxidation reaction is combustion. Combustion of alkenes. We see other two hydrocarbons under low combustion form carbon dioxide in water. So we say that when alkene is completely burnt in air, it forms carbon dioxide, and the water. So when alkenes or alkene react with this oxygen, the product will be carbon dioxide plus water. This is the example of combustion. Example, when a zinc undergo combustion, the product is carbon dioxide plus water. So how many number of carbons do you have here? 2. Then we have 2. How many number of hydrogens? 2. So how many oxygen atoms do you have? 4 plus 1 is 5. So simply, because you're advanced secondary student, this we can balance by 5/2. That is the first example of oxidation reaction, addition of oxygen. Second example, which will be the third chemical reactions of alkane, is oxidation with potassium permanganate solution. Oxidation of alkene with potassium permanganate. Oxidations of alkene is potassium permanganate solution. So we say that when alkynes is oxidizing with potassium permanganate solution, the products are 2 molecules of carboxylic acids. Molecules of carboxylic acid. So general molecular formula or molecular equation, general molecular equation, we have alkene So when alkane is being oxidized under potassium permanganate in acidic medium, so here we have oxidizing agent is potassium permanganate in acidic medium, then the product will be formed carboxylic acid, if alkynes with terminal triple bonds undergo oxidation with potassium permanganate, one of the products will be methanoic acid. But if alkyne with inner triple bond undergo oxidation with potassium permanganate in acidic medium, and the product is carboxylic acid. 4 molecules of carboxylic acid. Example. So here we don't have ketones and whatever, just like in alkynes. CH3, CH. So here we have so in this one undergoes oxidation is potassium permanganate in acidic medium. Product will be cyclopentine, cyclopentanic acid plus cyclopentine. So that's all about oxidation of alkenes. Oxidations of alkenes, I talked about combustion, and then talked about combustion, and I talked about oxidations of alkenes. Okay, so third chemical reaction is ozonolysis. Ozonolysis of alkynes. Ozonolysis of alkynes. This is not a type of oxidation reaction. So alkynes can react with ozone oxygen followed by reductive hydrolysis form two molecules of carboxylic acid. Form two molecules of carboxylic acid. So alkyne can react with ozone oxygen followed by reductive hydrolysis to form two molecules of carboxylic acid. General molecular formula is this. tetrachloromethane, and with presence of what? Of water. This reaction does not need zinc. So the products are 2 molecules of sulfuric acid. Simply this bond breakdown. It's just like in this oxidation reaction. For example, here we have a triple bond. So simply this bond breakdowns and this molecule form cyclopropyl methanoic acid, and the other ones form cyclopropyl. This is cyclopentyl methanoic acid, and this is cyclopropyl methanoic acid. For example, these molecules also here the double breakdowns. That's why we form ethanoic acid and methanoic acid. Similarly, in case of ozonolysis, means the triple bond breakdowns, that one molecule form carboxylic acid and the other molecule form carboxylic acid. So, to not claim, you have just to know that your ozonolysis reactions, how does it take place, especially for alkynes. It's not too much detail compared to ozonolysis of alkynes, because ozonolysis of alkenes, there are different categories. So, example for this case is, let's say serine, a triple bond here, then we have CH2, CH3, undergo ozonolysis under presence of tetrachloromethane and water. You should not confuse with what we have done in alkene. Then the product is triple bond breakdowns. Then we form what? We form ethanoic acid plus how many carbons? 1, 2, 3. So 2 carbons, 5 hydrogen, propanoic plus propanoic acid. So
the third carbon has.
So here there's 5 carbons, 5 bonds. Thank you. Okay, so the first reaction, which will be the fifth chemical reaction, and the fifth chemical reaction will be the homework. I'll leave it for you. This is reaction, chemical reaction between alkynes. So chemical reaction between alkynes. Chemical reaction between alkynes and the ammonical silver nitrate. or some of the books they call it tolerance reagent. Tolerance reagent. So chemical reaction between alkynes and the ammonical silver nitrate or tolerance reagent. Alkynes with terminal alkynes with terminal triple bond can react with tolerance reagent to form white precipitate silver organic compound from white precipitate silver organic compound. So alkanes with inner triple bond react with tolerance reagent. General molecular chemical formula. So this is alkene with terminal triple bond react with silver nitrate under presence of ammonia gas. Then the product here is this. So that's the white precipitate silver alkyne. So the homework there is show the mechanism of forming that compound. So why we say that alkyne with inner triple bond when they are treated with Tollens reagent. This is a very important reaction because it can be used to distinguish alkyne with triple bond, alkyne with inner triple bond, and terminal triple bond. That's why it's very important. So here, there is no reaction. So this is what we call the white precipitate. So white precipitate of silver alkyne. So example. First example, if you have this reaction, and here we have silver nitrate in the presence of ammonia gas, then the product will be CH3, C and this one, silver, like that. If you have and this one will go, it's chemical reaction, then the product will be a reaction between alkyne with inner triple bond and Tollens reaction. If you have any question about session 25, don't hesitate to ask it in the comment section of this video, and I'll try my level best to help you in order to catch up. So now it's a time for the students to think outside the box. So this is, I don't know whether it's example 14 or 15, not sure, but it's homework. Briefly explain the chemical reaction between alkynes with ammonium copper nitrate, ammonium copper 1 chloride, ammonium 1 chloride with aid of general molecular equation and 3 examples. So when you do that, you can now solve some questions of conversion, some questions of osmolysis for alkene, solve for alkyne. So it means that now we have increased more information for you to solve different problems about organic chemistry. So ladies and gentlemen, this is the end of session 25. I would like to take this opportunity to thank God who has been with me when I've been teaching you. And I would like to take this opportunity also to thank you who have been watching or have been learning this session 25 from the beginning to the end. And I really appreciate about your time. And may really God bless you. And you can watch this video several times as well as you can. And then these informations are built up in your mindset. If you have any question, any comment, any feedback, any testimony, anything else that you want to communicate with me through writing, please use the comment section below, and I will be happy to hear from you as you are happy to hear from me. I would like to take this opportunity also to invite all our students in session 26, 27, 28, 29, which actually be the sessions about alkyl halides and alcohol. So we'll be starting then another topic that called the alcohol or alkyl halides and the alcohols. That will be the third topic. We are done with saturated and unsaturated carbons, but later on we can add up some different questions, nectar as paper questions. So that's why that we don't close your mindset. We are trying our level best to summarize what we have to teach you, and actually to make this material affordable. Just when I say affordable, it means make this material simple as well as we can, and encourage the students to go through, because if we record maybe 200 videos of advanced organic chemistry, then some other students they can give up along the way. So stay tuned. Again, I would like to invite you, in case you feel from your heart that you want to offer your feeling thanksgiving to our God for what He has brought in your house, or in your class, or in your school, or anywhere in your field, in your farm, without any kinds of the payment that you've done in order to access this content. For myself, this is my feeling thanksgiving to God, who have given me a gift of teaching, and who have been teaching me on advanced organic chemistry for more than 15 years right now. So I say thank you to God, because I know that I believe if I offer my feeling thanksgiving to the Almighty God, He will reward me. Similarly to you, if offered by faith, He is with you and He will reward you. So you can just send your feeling thanksgiving through the telephone number 075-974-5331, and the confirmation name is Olenjolai. And I want to tell you that your thanksgiving will be used to pay the running cost of productions for the next sessions of advanced chemistry, advanced physics, advanced mathematics, and basic applied mathematics. So because we had an opening prayer, and we have seen the hand of God and His presence when we've been learning these contents, let us give Him thanks. Let us give our living God, at least for 1 minute, thanks publicly. And then it will be the end of this session, and you can enjoy your day with advanced organic chemistry. Our Father who is in heaven, we say thank you for this opportunity. We say thank you because you are the great God. We thank you for the bread of our mindset that you have given us today. I thank you myself for the energy, for the preparation that you have made, for the explanation, for the language, for everything that you've been speaking from inside me to your students. Father, I thank you also for the students who have learned this content from the beginnings to this point. And Father, I would like to ask you to help your students to trust everything that you've been doing for your glory, and receive all the praise and glory for this business that you've been doing in order to manifest the kingdoms of heaven in the world of science and mathematics. Thank you, and we invite you. Welcome again in the next session. We give you all the praise and glory for everything that it has been done here. Amen. So stay tuned and keep enjoying and watching these videos several times as well as we can until we meet in the next session. Thank you. Meet you in session 26.
Tuibariki Tanzania, dumisha uhuru na umoja, wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.